Awesome. Welcome to this week's Substrate Sync. The first thing on the agenda for today is UDT literal proposal for user-defined literals. And this is based on a conversation we had like a month and a half ago. But I think Josh was asking about like what do other systems do to handle user-defined type literals. And I kind of did a bit of a research blank, and it turns out they do a smorgasbord. Some systems only allow constructor functions. Some systems, like say when you define a UDT literal, you also define a string. So there's a whole bunch of stuff, but I kind of took that to heart, and I did two things. One is like, if we only allowed constructors, or if we only had constructor functions, if we didn't have UDT literals, like that we could write either expressions or tests, how far could we get? And the answer is actually quite far. In the agenda, like the first link there is like the comment thread where I kind of go through it. And the only place you start to get to some weird issues is like, how do you test constructor functions? And like, it gets a bit meta. But looking at that, I realized that with constructors, you can kind of work around the main tension I think we were talking about with the UDT literal discussion that we were having, which is it's nice to have a structure format that's kind of unambiguous and machine legible. So like it's infallible. You can encode and decode to it quite easily. But it's also nice to have a user readable format for writing tests. And I think what I ended up stumbling on is that if you combine use the structure function and focus that on being like machine legible, it's easier for machines to write. And then you can have human readable constructor functions that take, like, for example, strings to construct user-defined unsigned integers and stuff like that. You can kind of get to both worlds. And the proposal is basically, one, extend the current test format to allow for normal structs and map literals, actually. So we should be able to build those built-in types as literals to begin with. That's pretty straightforward, I think. And then two is use the struct literal format that we're going to add. And then you can construct UDT literals in tests using the structure format by just encoding them as a struct. So that's not that controversial because it also is how we construct literals in plans. So it's kind of just extending that to tests. And we can go a bit further and say for usability, in tests, if we want to use constructor functions in tests, the only difference is that we have to allow composition. So in the test, you have to be able to call like add, and then the constructor function for the type that you're doing, for example. And it's kind of like the proposal is just kind of like, here's the four things that we could do in sequence. And yeah, it's not super complicated. It mostly builds on existing kind of functionality in the spec. And the only thing that might be like a bit different is like, okay, in the test format, we want to allow function composition. But it also has like other nice properties for testing, I think, where you might be able to test like, is the left-hand side expression equal to the right-hand side? So yeah, I don't know if we should discuss it in this thing, but I just wanted to bring it up. But if anyone has any immediate questions, I'm happy to try and answer.
So Victor, I have some, I don't know, like fundamental issue with the struct encoding, which is it doesn't support optional, right? So like if you
find optional, say, or
yeah, you have like UDT, like let's say just protobuf. You have a some field, and like okay, second field I don't always have a value. So in that case, like what do we do?
You saying like it's a null, like you have a null or you don't have a value?
Well, null could be a value. I just don't know like what it's just value is not there. Let's say. we could put
more concrete.
Yeah, can you give more details? I think I don't quite understand what the constraint is.
So basically, let's say I have a type, like basically I just want to use, say, proto message. I want to define my UDT as a proto message, and I want to use this, like rely on this proto message evolution to evolve my type. So then okay, like and also like sometimes like a certain field it's a bag of field. I some field like I may not have like always a value, but then in today's world, without like actually, I mean I'm more alluding to like say name-based field resolution rather than office-based, or so basically, okay, I just want to populate like 16th value. I mean 16th field. In
Gotcha.
today, I believe I have to specify the rest of the 32 field in the things, but well, I just only want to populate the 16th.
I guess that might be related to the second point, which is like the unresolved expression PR that I think a bunch of us have been looking at. Is that?
Let's say it could be in that way, but I really don't care the rest of the build. Let's say.
Like you have a struct, you have like a type that's okay, this struct has like 4 fields, and actually I only want to make an instance of it where the other 3 fields are null and one of them is not null.
Something like that, yeah. Or
I think there's nothing stopping you from doing that with the struct encoding. Or like there's nothing stopping you from saying like, okay, in this field, ignore all the other ones and only set the one that you want.
But I mean, our syntax or does it allow that in more succinct way? So that
the structing like the constructing a struct literal in a succinct way in a test.
Yeah.
No, actually, that's kind of the thing as well. Where like the in the test, the struct literal encoding is very verbose, and it's obnoxiously verbose. But what you can do, go ahead.
I mean, not even like structural encoding in the test, but even our representation in the protobuf. Mm-hmm. When you encode it, I believe we need to spell out like every single field.
Yeah, you have to do it's like the protobuf UDT or UDT literal UDT. It's the structure that you have to give all the fields. Well, you can set the field to null. There's nothing stopping you from setting the field to null in that.
Right, but that's like I want to that's verbose, so I want to skip that if it is possible. So
yeah, especially that literal itself can be another UDT, right? So you have these multiple layers in principle.
That's true.
Actually, here's something I'm going to say. I don't actually disagree that I don't necessarily like the structure literal, but what I'm talking about is we already say that we support this and we can use this. If we want to have a different way to encode that, I'm also open to like a conversation. But I don't know, like if you want to redo how we handle structure literals or like UDT literal encodings, I'm actually open to having that conversation. I think that's separate from what I'm saying now, which is like we don't even have a way to do this now based on what we already kind of support.
Yeah.
And if we want to evolve that, I am open to evolving it.
Yeah. So I mean, just because I'm already talking about in this thing, because this actually happens in our real scenario. So we try to convey some extra custom information, try to fit in something into the substrate function argument, let's say. And this structure is not, I mean, initially, like we prototyped with like, yeah, let's use like a struct. And then, well, there's like, then it becomes like really fragile because now everything is like ordinal base. And if we add a field and remove the field in the future, there's like no systematic guard to against those changes. So in the end, like what we do is like we define like separate proto message over that arguments type, and then we just send a byte array, and then the receiving party will like, okay, I know like what this type is, and then deserialize the proto and then use the value. So it would be nice. Maybe this is like too much ask or too much thing to do, but if we can do a little more flexible structure encoding, that will be really, really nice, I think. Yeah.
I think it would be helpful for me, at least. Maybe this could come up in an issue discussion or something, but to just see like an example of an exact type with one particular structure encoding, and then an example of the bad representation or the undesirable representation as it shows up in a plan, because I'm struggling to understand this fields deprecation problem exactly. I don't know about anyone else, but
okay, I'll create an issue. I think this deserves some more discussions. Yeah.
No, 100%. And I mean, there's parts of the structure literal that I also find kind of obnoxious, where it's like, okay, except for the unsigned integer stuff that work, like what is it that working on this? It's like, okay, the U8 is like, oh, the struct is an IA, and in the plan I have to put like a struct for the IA field. It's like, why can't I just have like a bare IA and just be like, I don't need the whole struct around it. I just want to say this is a like, why do I have to nest it inside of the struct? Small stuff like that. There's definitely like usability stuff that I think is interesting. And then to your point about like extracting, I guess you're talking about like evolving a struct. So like you have a type with like 3 fields, and then you add a 4th field, and it's all ordinal based.
Yeah. Something like that. Yeah.
This is where I might get to a weird point where like you technically on UDTs we say that you can't actually extract fields based on the indices. You have to define like getter functions, don't you? Like in the spec we say this.
I need to go look at again. Read it
Yeah,
again.
I think that should
double
be
check
treated
this.
as opaque.
Yeah, the structure type is treated as an opaque type. You don't have in the plans, you're not allowed to or supposed to have any details about the structure encoding like leak into the plan itself. So that's the guidance. And there's also some questions about like, is that easy to understand, and are in practice are people using it differently, which is also kind of a thing where, you know, maybe it's not specified enough, or it's not clear enough, or the constraints are in place there.
Or maybe what we are really looking at is adding some sort of like extensions to the expression, maybe.
Yeah, adding extensions for. Can you repeat that? Sorry.
Yeah. So adding more like custom payload to, let's say, function call, for instance.
Mhm.
Yeah. So something that is not really our arguments, but something like some side channel information regarding that function call. I think that is more aligned our use case.
Yeah.
Anyway,
I think this will be easier also, like what I think Ben was asking for with an example.
Yes.
But think about what John Tool is describing as you have function arguments, like you have kind of user arguments for a function, right? What you would consider, you know, user inputs, and then you have some arguments that maybe are behavior changing for the function, something like that, or that the system kind of needs. And how do you define this and differentiate between these two, right? And that's why, you know, is it extension? Is it a more compact way of representing an argument? Is it something else that maybe would be good to standardize? I mean, we are doing our own way, like John Chu was alluding to, but you know, maybe there is a way that this can be standardized, and we don't need to have a custom way to do this. And by the way, compact representation plays a huge role for us. I mean, I'm sure John Chu has described this, but you know, our plans sometimes are humongous, and you know, this that seems like a small detail, it plays a huge role. It is very important. So there's also.
I'd be curious to hear about the use case for sure. And I'll link the section in the spec that I'm talking about in terms of like opaque access, but yeah, no, we can. I'm just thinking it's in issues and then talk about it next week or next time for sure. Yeah, I guess other than that, nothing on the utility proposal. Just kind of something that I've written up. People can take a look at it, and we might start implementing the. So it's already basically in the spec, and then maybe we'll add the feature requests for the composition. Yeah, I think I also have the next topic, which is the unresolved expression PR, where someone has been working on basically adding like the unknown type into the system based on a old issue. And I think the unknown type actually seems pretty reasonable. Like there's some edge cases to hammer out, but I think they did mix like the unknown type with like some name resolution stuff. And I think at least 3 of us have been like, okay, this should make a separate PR just for the unknown type.
I think everyone agrees that.
Yeah. Okay. So I think when that happens, we can talk about it there, and I might even push back on this person for like when they get to the next step about name stuff. Let's talk about that first before we even if I get too far in that implementation or that specification.
I think just my take on this is I think it is good, but I think we need to be really systematic. So if we go down like this path, every entity could be unknown, let's say, like types, functions, schema, or even relation. expression.
Functions be unknown. Okay, right.
Let's say just expression. Yeah, just. But function is also kind of. I mean, you had a comment, right? So, the only thing that I know about this function is add.
Yeah, it's called add. It's like, well, which add and which extension are you doing? And like, do we need to standardize the lookup, or do we even care? Or do we say it's up to the consumer to transform this into a valid plan? Do we say that like plans of unknown have unbound unspecified behavior until they are bound? And in the spec, we don't say how you bind this. We just say like, hey, there's unresolved behavior that you need to resolve in whatever way you want for your system, and only at that point is it a valid substrate plan. Like maybe that's okay to have that whole, but I would want to specify it. And then, yeah, to your point, you control things like, okay, if you have a function that returns an unknown type, it technically means that every function that calls that or uses that field is also unknown, so it propagates up the tree. So like,
exactly,
how do you handle resolution?
It just like, if you have like one unknown, like everything upward is just unknown. Like I mean, so at that point, I mentioned a couple of points. Like there's like nothing you need to do, like nullability or whatever. You need to do the rederivation anyway. So just to leave it as a just pure whole, and then when you bind it, like you do the right thing. I think that but I think overall, I think it's a useful thing to just be able to use it as a IR. Is exactly intermediate representation. I think it's a very valuable. Yeah.
And it's a good point to make about the nullability. Oh, go ahead, Ben.
Do you at Microsoft have a concrete use case for this particular thing that this change would solve, being able to represent an unknown type?
No.
Wish one of the IBM folks was here to talk about it. I think Mullen.
Yeah, it looks like Neil has some interest. But for us, no. Like everything is known. But maybe
I actually can understand the setup a little bit, where like your parser is not on the same system as your reader. Maybe you're doing like Python data frame stuff where you don't know the base steps until you go to fetch them, and all you have is a name, and you assume the name is valid, and maybe it fails later at like resolution time.
Yeah, or I mean, if you think about like lazy binding, like everything, like you just have a script, let's say. And then it's parsed like, okay, it's syntactically it's parsing, so you have AST, and then you just, okay, I try to inline this script in somewhere in the pipeline, and then now I need to resolve it. So maybe that's a use case. Maybe I don't know. Yeah.
But, yeah, I guess I just am curious to hear more about what the intended use case will end up being, because to me it does not seem like a trivial change. Like we already have difficulties with the type system already. And I guess this is sort of like a type system backdoor to say, just treat anything else in the type system or any other type deductions you can make about this plan as unresolved with the presence of this unknown type. But I would be curious to see the use case in a little bit more detail, because if it feels very specific to one use case, then I just feel a little apprehensive about introducing it is all. It makes me a bit nervous.
I see. I think
that's exactly, I think, where we're all like, it should be its own PR, so we can talk about the implications of just the unknown stuff separate from the like, okay, we want the named expression, which is like, what is that even for, and stuff like that.
The examples really help, right? More concrete scenario.
They help.
Yeah, I mean, I ask like, can you a little bit elaborate the examples? And I think I had a comment in the beginning. He tried to elaborate a little bit, but like, feels like
I think we can comfortably ask for like, could you give a more in-depth example, please? We're just trying to reason about this and make sure that we understand your use case and the implications. I think it's valid for us to be like, could you more than just like a high-level scheme, like what would a plan look like and what would this resolution look like for you?
I am curious. I know I'm asking to reach back multiple years in your memory, Weston, but it looks like the original impetus for this PR was an issue you opened, and the solution is following, I think, pretty closely what you suggested as a possible solution. Again, I realize it's been years since that issue has been open, but I'm curious if you remember at all the context with which you wanted to introduce this.
Yeah, it was, we were trying to use Substrate to interop with Spark Connect. And Spark Connect works at the unresolved plan level, so it doesn't do the resolution before it sends its stuff down. It's very, very early in the pipeline. It's just, the PySpark is like a Python front end for writing SQL, basically. And Spark Connect, it's half IR, half still SQL. And we wanted to use Substrate instead.
Yeah. And I think maybe there's a metaphysics guy. I did see this original issue. It's like, you're trying to implement an issue from 3 years ago. The thinking of that may have changed between now and then as well. Actually, I look at that. I'm like, no, the canonicalized unknown type, that makes sense. And I look at your named expression thing. It's like we have extended expressions of names at home already. Like you can put a name just because it has an unknown type. And I think it's the difference between like you can say like, hey, this thing only has this name, or we have these names that we assume exist in nothing else. And when you're reparsing the scan of access to the schema, maybe you actually know that it's wider, but then it's your job as the resolver to be like, oh, I have these names, but actually it's part of this bigger field. I have to resolve the names and then like reorder them to match the existing plan, which is kind of somewhat standard. Like you can massage it both from the producer and the consumer to realign the indices basically as needed, which is something that we do a lot in CalSite actually.
Yeah, and the context we were in, at least, it was like, okay, a plan is either going to be completely unknown or fully resolved. Like we didn't have to worry about partially unknown plans.
Yeah. I mean, would it be any different if it was like, the plan was fully unknown either? Because I guess like the most basic case for the plan is like you have access to either just like a bunch of names for fields or even a table in those fields, and it's just like, well, you have these names and you know the types and you want to do some operations on them, and when you resolve the types, resolve the names for the proper types, you have to propagate it up, and like that already. I think we can support that already, roughly. Like with the unknown type, if you can do that, you can bind and say that this name has an unknown type. When you resolve it, then just inject it in. Yeah.
Yeah, I think you just lose validation.
Yeah. I mean, that's a good question about validation. It's like when you start building these, you'll probably have to change a bunch of validate. Well, if your system cares about consuming these, or you try building them, it'll change the validation rules slightly depending if it's unknown. Because like a lot of the validations, I think some in Substrate Go assume that like when you have a function, it exists in that extension in that catalog, versus unknown is being used as a like anything with unknown. It's like a dynamically populated, like this may or may not exist at some point in the future, but like ignore it for now and assume it's valid. So it has like validation implications, and I don't think it's intractable. It's just I think it requires like what are the actual implications of punching a hole in a type system like this. Yeah. I think we can continue the conversation in the people. Go ahead.
No, I was just say it's like TypeScript anytime. Or no, they actually moved it now. They have any and unknown. So the
yeah, because any is like we actually don't care what the type is, and unknown is we don't know what the type is yet.
Yeah, it's just like any is unknown is before you use this, you have to cast it to a concrete type. And we'll just trust that you know what it actually is at that point. And then any is probably closer to what we're proposing as unknown, which is just like this could just magically be used anywhere. We'll assume it works, and the return value will be idiot.
Perfect. Yeah, we'll continue in the PR. I think we have a path forward for them. And I guess Ben, the last item right now is yours, which is clarify the nullability modeling for array append style functions.
Yeah, this one doesn't necessarily need to be, let me share my screen briefly because I think it'll just be easier to just look at it for a second. But this one, let's see, window. Oh man, I'm in some, like, I don't have the appropriate permissions to share.
Yeah, I can share it.
Mac.
Okay.
I can share it then.
Uh,
I think.
Okay, just the linked issue there. Just basically, we've been having some issues internally where
There you go.
the interaction of nullability handling with any type parameters gets very confusing. There was a change that I contributed recently which aimed to clarify it. And it did clarify, I think, some set of cases, but a new edge case came up internally. So, for example, looking at this array append with nullability mirror, the difficulty now is that we want to be able to use array append in cases where the list is itself a list of nullable strings. And there's just an ambiguity now, which is kind of related to the fact that when the second argument is nullable, is that meant to be interpreted as we passed a null argument into an array append, so now the whole thing is null? Or is it meant to be interpreted as we passed a nullable argument in, but the type parameter is binding to the nullable parameter, so the list is over the nullable parameter? Hopefully looking at this issue makes what I said clearer, because I feel like it's kind of hard to verbalize this type parameter tomfoolery. But yeah, if anyone has any opinions on how we could try and resolve this problem in general, that would be greatly appreciated. I am also trying to think about it too.
This has also opened up I noticed something else about this, where like we have this concept like discrete nullability, where your function has to match like the nullability, right? But if I understand this correctly, that means that, you might have a function with the same types of different nullabilities. So you have implementations of different nullability requirements in the same file, but the function signature doesn't include the nullabilities. So technically they would collide for discrete. If you define multiple functions with the same arguments of different nullabilities in the same file, you get like a namespace collision, basically, in the way that we do it today.
Unless
as
you
well.
give them different names, of course.
Unless you give them different names.
The array append is receiving the destination array, right? As an argument.
Not even destination. It's like it takes a list of elements and then like an element, and it appends the element into that list.
I see.
There's nothing about destination. It's just like it's a pure function for all perspectives, or for all extensive purposes.
And then returns new array.
Yeah.
I see. Not in place, but yeah, returns new array.
Actually, maybe the other example here is like if you have array append that takes like a list of non-nullable elements, and you add a nullable element, then the final output is now a list of nullable elements, right? Because you potentially put a null into it, right?
Right.
Well, there's no way to model that in kind of like the current thing without getting fancy with discrete.
I see.
Well, I don't know. Is that the intention, or are you saying I passed an element which might be null, but if it's an actual value, you append it, and if it were actually null, then the whole thing returns null?
Well, it depends on the definition of like how you implement the function of the definition. I think with mirror it has to be null. Does it?
With mirror, the output has to be nullable, not necessarily null.
Right. Yeah, mirror is like, if any arguments is nullable, then the output should be nullable. However, in this case, for the list, okay, there's a list itself may be nullable, or the elements is nullable. So there's like element nullability and the container nullability. And I think we decided this nullability applies to the container, not the elements, right?
Yeah.
Yes.
Yeah.
So then the point is, in the current version of the spec, if you scroll up slightly to just the definition, in the current version of the spec, we would strip the nullability off of string in the second argument before binding it to any one. So then the expectation is that the first argument is a list of non-nullable strings. So now we have conflicting any one definitions, and that's why it would not bind. So, I mean,
go ahead.
There's maybe one interpretation, which is to just say, like, this isn't a problem. This is just an invalid invocation. And if you want to do this invocation, you need to have array append underscore my special nullable case or whatever, which is discrete and handles that extra null, but that feels like bending over backwards for a very reasonable use case, I would think.
Something I want to ask, and maybe this is just getting the temperature. How many people feel like they actually understand how like mirror and like discrete and declared output work in all cases? I guess both for like compound and non-compound types.
I mean,
I don't.
Well, I think I understand exactly what the spec says because of how much time I've thought about it, and then I've now written the current version of the spec on that. But I can't promise that it's consistent logically in every case.
I mean, yeah, it makes
I
sense.
have
Go ahead. Zé.
sorry, I was gonna make a joke that I have another version that is that, you know, I check the spec, I learn it for like 1 day, 2 days, then I forget about it for like 2 months, 3 months until I have to come back to add something else, right? I mean, it is, yeah, a bit confusing. Yeah.
I
Like,
would
I
be
think-
okay with it being simplified if we can come up with a simplification.
I guess yeah. This is like a polite way of me asking like how tied are people like to the concept of having like nullability expressed with mirror and declared output and discrete. So I think what we're starting to run into like the limits to some extent of like it wasn't really a problem, or it mostly seemed tractable when you were working with like the primitive functions taking primitive types. But I feel like as soon as we started to be like, okay, we have functions that consume compound types, then we really have to like bend over backwards to like retrofit or to like extend the definition. And the fact that we have conversations where like, okay, for discrete, you have to strip the nullability. No, for declared output, you sorry, Ben, which one is it? For mirror, you strip the nullability, and then it's like
For
it's like
declared
things
output
like
and
that
mirror,
where,
you strip the nullability, but not discrete.
Yeah.
like if you come up with like a newer, like a simpler model to express the things that we want. I don't know if simpler is necessarily a word, but like
Well, there's
an
always
alternative
this
mechanism.
simpler model, which I am reminded of Jacques saying one time when this came up many months ago, quote, "No one cares about nullability." And we could embrace that as part of the spec, which is to just say nullability unification is part of the spec. We can handle when like two anyone's, one is nullable and one's not, and we just unify to the nullable one, and we drop all of the nullability handling business, and we just simplify in that way. We're just pushing the complexity in another place, though.
Yeah.
Yeah. I mean, I don't know. Like I'm not like really qualified to comment on this, like dealing with the complex type. I mean, there's a reason why it's a complex type.
Yeah.
And also any big
yeah.
change we would do, we would also have to figure out how to unwind out of this mess too.
Right.
So
Yeah.
It's not.
We
no,
couldn't
it's
just
not a
change
mess. It's been a pain point for a while in both a number of systems, like how you do the nullability, and I think we're just trying to. I feel like it's like with any solution. Once you start to add enough like complexity in cases, you start to run into the limitations of it. Even tangential related to nullability, the fact that like,
Yeah.
what if you want to declare a function that consumes not a list of any, but specifically a list of string? It's like, I want to implement join, but the join only applies to list of string, list of varchar. Like you can't actually declare functions that take compound types of specific input types, right? Which is maybe a feature that people might want.
wait, sorry, why can't you do that? Can't you just, as one of your arguments,
Oh, no, you're right. I could do a list of string, but then if you want to have like, I
Well,
want to
you
have
can't do-
list of varchar, list of, then that doesn't work because those collide.
I think
Yes, that's true.
I think some of these challenges are actually, it appears to me that it's because, I don't know, like this thing perhaps maybe shouldn't handled as a function more, or let's say more. I mean, it's hard to reason about what the function actually will do, and I don't know, like and maybe we could come up with, I don't know, 3 or 4 more different variations of how we derive the nullability. But yeah,
I've been doing a bit of like a building up on the survey of the type system and kind of some of the gaps that like pop up in various places to try and figure out like what are the limits of what we can and cannot do right now.
At some point, like, I don't know, like, how should I put this? So basically, like, basic operations over these like basic compound types should be, I think it should be just natively supported, and so all like insert, add, like all these things should be handled like natively, not as some separate functions. So that will, I don't know, somehow for those. So then we have like solid foundation, like, but then there's like something like random, like, oh, I do some fancy things or the things, then like I don't know, like what the correct nullability is, right?
I mean, actually, even prefacing this discussion, like even before like the list stuff, like coalesce is an interesting type because you can't really model coalesce with like mirrored or code output, where like the nullability mode for coalesce is technically if any of the inputs is not nullable, the output is not nullable, which is it's not mirror, it's the opposite of mirror basically, but it's not like declared output either. It's like it interacts with variadics in a fun way too. Like, okay, I guess to be fair,
well, that was an issue too. That
it's just the question was less about like, can we solve it? But we're like, okay, it sounds like there are limits in the type system as we have it today, and maybe we might need to do some like deeper changes to like work around them. And no one seems to be like particularly wedded to the way that we do it today. So maybe we can figure out a way that captures like the new use cases that we've kind of found with time. Like, can we find a new unified model for a type system version 2? Okay. Maybe I'll ask Claude.
I think for us, we are not really interoperating, so we just rely on the correctness of type system of our systems, and then we just serialize, and then we don't really validate. Take it as
I guess for us, we have 3 different type systems at play, which is one is like our parser doing its best to attempt derivation from SQL to like substrate plans, and then we have the going from substrate to calcite, which calcite will explode in some cases if the nullabilities don't line up, which is a source of problems for us. And then we generate those systems of data fusion, which I think today currently just ignores all nullability anyway. So that's we do a bunch of work there. But eventually we would like to cohere it. And I guess the Ben's point is a question about like, what should we care about nullability at all? And I tend to be in the yes, I care about it because I think it is for like optimizations to know when things are nullable and not nullable. Because like there are changes that you can make to plans for performance reasons. Right. But then it's like, what's the best way to express that? It's like a different question.
Yeah.
I mean, the tension that we deal internally, I feel a lot with the parser side of our system who are actually producing the substrate is they're very much in the we don't care about nullability camp. So there's just always this friction where they want to just be able to say that something is a type, but instead they're forced to specify its nullability at that particular moment in the plan. And if it's somehow inconsistent with the substrate, then it poses an issue downstream. So then we patch it in substrate Go because it's being produced in Go. And all of a sudden, something that used to not be an error becomes an error for them. And so there's just this like constant massaging of our type issues up from substrate into the parser itself.
But also a more generic version of the problem is that there seems to be 2 schools of thought for all of this stuff. It's either your type system, your types have nullability information attached to them, which is what calcite does, or your type system has types and then nullability is a separate axis, which is what like our SQL parsers do. But there's also what data fusion does. Right? Data fusion with arrow is like, Postgres as well. Like data fusion with arrow is like you have your arrow column type, and then the nullability is attached to like it's not part of the type itself. At least maybe in data fusion, I don't know about arrow. But like, it's not even just like an us problem. It's like there's like 2 schools for like some people nullability is part of the type, and for some it's not. And that's also like an impedance mismatch in some places. Yeah. Cool. But this is helpful for me because I've been thinking about if I open myself up to more radical changes, and it's like, okay, what can we want to identify all the weird stuff we want to be able to model? Like, can we find it maybe more complicated for some basic things, but simpler for more complicated things, like middle ground?
I'm always pro radically simple ideas, provided we have a path to get there too.
Yeah, we have to migrate to it. Cool. I think it's it for like agenda items. But we have another 15 minutes. We don't need to use them, but we can. If you have a topic, Ben.
Yeah, I do have one more thing that I am curious people's feedback on. This is actually not really Substrate specific, although it is causing issues for us with our usage of Substrate, which is basically that the way the underlying generated Go code from the protobufs is versioned is it is tied exactly to the Substrate version. So for example, if we're on version 0.91.0, I think that's right, then Substrate Go has a dependency, Substrate protobuf, which is 0.91.0. And as a consequence, we are always dealing with difficulty because of the fact that our whole mono repo setup can only have one version of the protobuf available at a time because of the way Go packaging works, where you can only have one version of a pre 1.0 package available at once. And
I actually have an example of how this breaks, by the way. It's an open source repo. It's not just an us thing.
And I'm curious if anyone knows like what the best canonical solution for this kind of problem is. I've talked about it with Victor before, and he pointed out how protobuf versioning works for their own libraries, which is that proto-C, I think, just drops major versions entirely, and it's just minor and patch. And then the language implementers have their own major version. Maybe that's something we approach, but surely we are not the only ones dealing with this problem. So,
and maybe to be a bit more specific, the issue that seems to arise, at least in Go, and I believe in Rust as well, is that in theory, in the semantic versioning spec, pre 1.0 versions, like if you have like a minor version of it, like a 0 version, that's supposed to be a breaking change. But the way that Go does module resolution, it's like if you have multiple modules depending on a pre 1.0 package, like it picks the most recent one basically, or it picks the latest one. But if you have breaking changes between those two things, that's a problem. And historically, it wasn't been an issue for us because no one else is using Substrate Go. And then we discovered that Iceberg Go is using Substrate Go for something. And the issue has to be that they have one version, we pull in a version of a different version, and then everything explodes. And there might be a way forward by changing how we do the versioning of the generated code to actually care about breaking changes within like the language and not just the spec. I'm planning on writing something about that, but I have a little repo where I kind of go like, you can try building that example, and the fun thing is it's not even like you can make intentional breaking changes to like the protobufs and document them as such, but even non-breaking changes in the protobufs according to protobuf can result in breaking code changes in Go. So like you can get this to happen unintentionally. I believe Rust is the same thing with like pre 1.0 versions where like it'll pick the latest one. It doesn't treat them as separate or as breaking changes. But yeah.
I think the rest you choose and the default is that 0.1 to 0.2 is a breaking change.
Could you repeat that? Sorry, Weston?
In Rust, I think you can choose, but the default, if you don't use any special characters, is that 0.1 to 0.2 is a breaking change.
I think that's a good point. I think I was saying that, yeah, you can specify that don't go above this version. If you have two packages that have it above that version, they'll pick the bare minimum. Or they'll pull both into the tree. The issue just seems to be like Go doesn't. Go is like, these are compatible. But yeah, I'm probably going to write something else about this as well, and I might update the Substrate packaging work that we've been doing to deal with that.
So I think this is actually quite interesting. So if your dependency, I mean, if you have two dependency, explicitly depend on two different substrate version, and one of them have a higher version which introducing breaking dependence, breaking change. Then okay, then like the moment you just pick one, you're guaranteed to be broken, right?
I mean, if you're using any of the functionality that requires the breaking stuff, then yeah.
Yeah. Assuming that like these dependencies are very heavy substrate package, then you're destined to break, because either way you're broken. Then
I guess what I'll say there is the nice thing is that I would rather be broken at after compile time, so I can try to fix it in code than be stuck in dependency hell of like, oh, I can't upgrade either of these because I try to upgrade one, the other one breaks. If I try to upgrade the other one breaks. Like the issue right now is that we can't even bump code. We have workarounds that we can do, but I suspect that we're the primary people feeling this stuff because trying to use a lot of stuff in the ecosystem, but I suspect that other folks will start to run into it as Substrate gets more popular. So I think what Ben was saying, we talked about this before in a previous meeting where we could go to a scheme where in the Substrate spec we only use the major and minor versions, so we never use patch. So we restrict it to the first two digits, and then all the libraries are the major version is for library like code breaking changes in the language, and then minor and patch correspond to the spec. We could also just fully move and say that the language, like the libraries, have their own version that's not tied to the spec. And that's like going completely the other way is like just treat the library like the protobuf generated code as its own thing with its own version number. It does feel a bit weird to try to figure out what the association is if you care about that stuff.
Right. Yeah.
I mean, I basically just wanted. I wish that there was a clear answer, but I want to do whatever is the more standard Go thing to do in this situation with the better tooling to support doing exactly that and not think about it. This just feels like it should be such a common problem for any spec that's based off of protobus that's pre 1.0 that I would expect it to be solved, but maybe I'm expecting too much.
I mean, it's probably solved at Google, but we're outside of Google, unfortunately.
And the other thing I was just going to say about this, which is also unique to the Go situation, is that Substrate Go, the package, is post 1.0, which doesn't really matter that much for this conversation, except just to say that there's kind of like a funny consequence of the fact that because it's post 1.0, you would expect that you can have both V7 and V8 installed, because that's like a desirable feature of the Go ecosystem, that you can have both of those major versions. But you quite literally cannot because of this blocker from the underlying dependency on Substrate protobuf pre 1.0. So there's almost not even a point in being post 1.0, even though I know that was an accident in the first place, but it's functionally like
Iceberg Go depends on like V7, and we try to pull in V8. They have different protobuf versions, so they have different pre 1.0 Substrate protobuf versions. You pick one of them, and depending on which one you pick, you either break Substrate Go or you break Iceberg Go.
Yeah.
No, I don't know if it's a standard solution for this or a standard solution for this across all language libraries, but we can try and figure something out. Yeah, I guess it's like
I don't know if we need
for knowledge. Go ahead.
I don't know if we need to come up with a standard solution across every language library, because I feel like this is just going to show that there are all their special little snowflakes, and they each have their own challenges. Yeah.
I think this is pretty generic problem. I mean, we are also internally experiencing some similar issue.
Is it also with Go?
No. We have like nothing to do with the Go. But it's C++, and we have there's like its own problem with the like one package goes right and like go log and no one is doing that, so why don't we do this? And then suddenly that creates like implicit dependency to everyone else, and now we are stuck. And I
actually had been meaning to ask, because I was curious if at Microsoft you use any of the open source Substrate packages. Do you use Substrate C++ or is it an internal version to Microsoft?
No, we are just compiling. We just we depend on the proto definitions, and we just compile and do it. Because there are other options. For instance, like protobuf code generation has an options, like for instance, like for the strings and bytes, like which do you prefer FSA chord or string view or just a regular string? Those options are there. So we'd better to just we want like some control over the generated code. So that's why we are not directly consuming the C++, and there are a bunch of other reasons as well. Yeah,
makes sense. It's good to know that you're using you're compiling by itself. It's good to know who's using the libraries versus not. I think that's also plays into like the pain points.
Yes. Yeah.
Is there any other topics for the meeting? I'm happy we can discuss, but otherwise I think I can let people go. Or I can stop recording. We can talk about Go for real. No. I mean, if there's something else, yeah, I can let you all go.
All right.
See everyone.
Everyone,
Yeah.
thank you.
Thank you, everyone.
Bye.
Thank you, everyone. Bye.
Uh-huh.